Try measuring a curved object with a straight ruler. It is geometrically frustrating to calculate an exact boundary when your standard tools refuse to bend. But by the end of this session, you will have the exact formulas required to map any circle, find its diameter, and calculate its precise circumference. Grab a piece of paper and a pencil. We are going to work through a live mathematical problem together in a few minutes. Conquering the math behind circles provides the specific tools needed to accurately measure and engineer the physical world. Step 1 is establishing a clean workspace and deconstructing the circle into its component parts. Look at this digital grid. Right in the middle, we have a single dot. This is the center, the absolute anchor point from which the entire shape is generated. The continuous outer boundary that stays perfectly equidistant from that center point is the circumference. A straight line originating at the center and terminating exactly at the circumference is called the radius. There is a core mathematical rule here. Every single radius drawn within the same circle possesses the exact same length. Now, a line crossing from one edge of the circumference to the other, while strictly passing through the center point, is the diameter. In contrast, a chord connects 2 points on the edge, but it completely misses the center point. Knowing the strict geometric difference between these lines, especially identifying a chord versus a diameter, is your primary defense against calculation errors. Now we can look at the mathematical relationship between the radius and the diameter. You only ever need to know one measurement to find the other. On screen is the formula for finding the diameter. You simply multiply your given radius by 2. If you have a radius of 12 meters, you multiply it by 2, giving you a diameter of 24 meters. The inverse formula applies for finding the radius. You divide the known diameter exactly in half, so a diameter of 9 translates directly into a radius of 4.5. Because a diameter is inherently just 2 radii glued together, these measurements are perfectly interchangeable if you apply the correct rule. Now for the ultimate goal, calculating the exact length of the circumference using the internal measurements we just mapped. This is our foundational circumference formula. It states that circumference equals pi times the diameter. The mathematical constant of pi represents a universal ratio. It has 2 accepted numerical values, 3.14 and the fraction 22/7. Test questions will often specify which value to use. When they leave it open, 3.14 is the standard choice for decimal-based math. This formula takes your straight diameter and scales it up using that universal constant to perfectly wrap around the shape. Let's apply everything you've learned. We are going to calculate the circumference of a circle with a diameter of 4. On the right side of this split screen, we start our workflow by writing out the empty base formula. Next, we substitute our specific values. We choose the decimal version of pi, 3.14, and multiply it by our diameter of 4. Set up the vertical multiplication. Calculate the numbers, tracking the decimal point carefully, and drop it exactly 2 spaces from the right. This gives us our exact raw output, 12.56 centimeters. We can apply a final polish by rounding that raw decimal to the nearest tenth, leaving us with 12.6 centimeters. By plotting the data, substituting variables, and managing decimals, you have calculated the circle's exact mathematical size. You just successfully applied the fundamental geometric principles and the precise mathematical steps required to solve that calculation. You mapped the internal anatomy, doubled the radius into a diameter, and accurately multiplied by pi. Here is your final homework challenge. Calculate the circumference for a circle with a radius of 8. Remember, you must convert that radius into a diameter first. Mastering these laws allows us to translate the natural world's curves into precise, actionable data.